How are you guys? Fine, okay. Huh? Exceptionally ordinary. Then what's so exceptional about that? Okay, it's supposed to be sarcasm. Fine. Alright. How's school going? No school, no college. Why? Okay. Vacations right now then? So you guys are like preparing early so you can be the best in class or something like that. Huh? You want to make the others fear when they join classes because you'll be answering before them. They'll be like, what is this? They'll be all confused. That's the plan. Huh? Okay, so I hope things from last class are pretty clear. Hello Ananya, can you hear me? Can you hear me? Okay, fine. So I hope things from last class are pretty clear, and if all things go well, we may finish this unit today. Okay? So more than me, the responsibility kind of lies on your shoulders because you have to go home and you have to go through this stuff again. And see, the thing is, it's very easy for you to understand things because maybe I simplify concepts are here, but it's also quite easy for things to get out of your head. Okay? Any doubt, man?
From the previous problem,
yes.
I understood the previously that mean value, mean absolute error, relative error, and so, but I didn't understand what is percentage error.
Percentage error is when you multiply it into 100, so you have the same value in a percentage format.
The same value of what? Relative error.
Huh.
Relative error we will
multiply into 100, so you get it in terms of percentage. Otherwise it will be maybe 0.4 and you multiply into 100, you get 40%. So that's just two ways of saying the same thing.
The same relative error we are converting into percentage and
we are telling it, representing it, that's all. It's a different way of representation of the same value. That's all. Alright? It's like how you say for half you can say 1/2 also, you can say 0.5 also. Both mean the same thing. Alright? We'll start? Alright, so today we start with some interesting things. Last class we looked into errors, absolute error, relative error and things like that. Today we will look into what else can be done with errors, and hopefully we will, let's rush things up, we'll finish things off today. Okay? The conceptually at least we'll make it clear. Remaining things you can go home, since you're on holiday, you can go through stuff, you can solve some things here and there, and you should be good to go. Alright, so now we're going to look at this. Okay, now what if we have a combination of errors? That's what we are going to look into now. Combination of errors. Alright. So it may often be that you are working with a particular system wherein there are multiple errors, not just one. And now we are going to look at how we are going to, combine these errors and how to do this, how to quantify this. Okay. So if there is an error in the sum of two quantities, the errors are obviously added. Okay. For example, if you want, let's say, the total length of one particular road, okay, and I break this road into A and B, and in the measurement of A I made an error of, let's say, delta E1. In the measurement of the road length B, again I made an error of delta E2, So if I want to know my total length A plus B, okay, that I will know. But what are the errors? What is the total error? That will also get added, delta E1 plus delta E2. Okay, this is quite simple. And all of this can be plus or minus.
Can be plus or minus.
These within the bracket it's getting added. So it's like saying I have one problem, I have another problem. Both of these problems are getting added up. But I don't know if the problem is contributing to it or it can be subtracted from it. You're getting it. Error can be plus or minus. Remember from last class, I don't want to repeat things again and again.
Yeah.
Okay, good. Now, the interesting thing is, if there is error in the difference of two quantities, also it gets added. Okay, the form, it remains the same. So your total, it's given this way, delta x is going to be plus or minus delta A plus delta B. Same thing. If the errors are getting added or they are getting subtracted, the formula remains the same. You must be thinking, why? When it is getting subtracted, why are the errors adding up? Correct? No? Let me tell you. So now, for example, I have this particular length, it's A. I have another particular length, B. I want to find C. Alright? C is going to be my A minus B, obviously. But now I have made an error. Meaning, when measuring A, I have made one problem. While measuring B, I have made another problem. Let's call it a problem or an issue. The issues never get subtracted, the issues only get added up. You getting it? If you have two problems, you cannot say the first problem and the second problem cancel each other out. That doesn't make sense. You are only going to have more problems. You're getting the idea? You cannot say the first problem and the second problem cancelled each other out. You say two problems is added up to become a bigger problem. Mistakes can only get added up. They cannot be subtracted. Getting it, no? Alright. So that is the logic. Similarly, now the thing is, when we have the product of two quantities, okay, when there is an error in the product of two quantities, what we are going to do is, we are going to take our relative error and we are going to add it up. Okay. So your delta x by x is going to be plus or minus delta A by A plus or minus delta B by B. Okay.
So this sum of two quantities error is represented by delta.
You can do whatever you want. In your book it's given delta A for one error, delta B for another error. You can call it delta A1, delta A2. You could call it delta A1, delta A2. It doesn't matter. It's not a fixed term. It's not like force is F. No, that's not how it is here.
Delta something.
Delta something. Up to you. Understood? This one? Combination of errors. Right now we are talking about product. We talked about sum, we talked about difference. Now I am talking about product. Yeah. In product, the relative error, you taking C, you know what is the error by the original value or the true value, you add it up or you subtract it depending on the sign. Okay. So that's what happens are here. And for the difference C, but you must be thinking, where is this happening? Where am I going to see a product of errors? If that is your doubt, we already have so many equations. For example, F is equal to this is second law of Newton, man. I wrote it, it's correct only, just I didn't write it nicely, so I erased it. Force is equal to mass into acceleration. Let's say you are weighing something, you made an error. You are measuring its acceleration, there also you made an error. So the two errors are getting multiplied to give you the total error in the force. Okay, so let's look at this. For example, now look at this maybe. See, I take a reading of the mass and I make an error delta m. So I take the reading of acceleration, I again make an error delta a. Alright. So how do I get the product of these two errors? Delta m by the original value plus delta a by the original value. Now if delta true value or mean,
True value.
it's
That will not be given.
if it is given to you, then that is your true value. If the value is not given to you, then you take the mean and that is taken as the true value.
Here only one value is given.
Then that is your true value. That's all. No struggle over there. The only reason we are taking mean is because we don't have true value. If we have it, then there is no problem at all. Clear? Similarly, the formula remains the same for division. Okay? Because again, the same logic.
The same thing.
Similar logic, yeah. Correct. Okay? So, now but what happens if you have a quantity, let's say there is an x and there is an exponential a raised to n times, let's say, b raised to m, something like this. So what I am going to do is I am going to again take delta a by a, and from where is this message sound coming? It's not my phone. Delta b by b, okay, same thing. But now what I am going to do is I am going to multiply their individual powers in front of them, n into m into. Getting it? N into same thing, power into this thing. Because the thing is, if A has a measurement problem, see, let's say,
Excuse me, sir.
yes,
The error is in A, not the exponent of A.
yes, exactly. So exactly, if you have a banana, okay, one banana, and if you have, let's say, you do it into 3 times, let's say you have 2 bananas and you take its power to the 3, what is that?
2 raised to power
Yes,
3.
and you look at the screen and then it is, so it's 8 bananas. This is common sense. I have taken a bite of these 2 bananas.
So now we have 6 bananas.
So if I again cube it,
We are cubing 2.
the bites also,
Then we don't have any bananas that is.
jokes aside,
No, sir.
but you're getting the idea, no? See, the thing is, I'm taking one fundamental quantity. There is an error in my fundamental quantity. I'm raising it by some power. So every time I'm multiplying it by itself, the error is also getting multiplied in that.
Okay, it implies that the error is also multiplied.
Being multiplied.
Okay, yes.
That's all.
But we didn't have any error in the exponent. We had only
What is the exponent? The exponent is C. If I tell you 2 to the power 3, this means 2 into 2 into 2. So it is my 2 which is getting multiplied. How many times? That is what power is telling me. So if there is an error in this 2 only, the error into error, it is getting multiplied.
So
But we don't have a multiplication of errors, we have summation of errors. So what would be? Your power would come in the front and you would multiply it into 3 times the error, I can say.
Oh,
So that is what you are doing here.
will it only be positive or only plus will come or plus?
That depends on the sign. Or see, because from here, error in the power of the quantity, they have said it is positive. In the previous case, they have said it could be plus or minus. But I believe when we solve problems, we'll have clarity on this, like we did yesterday as well. Okay? Is this much clear to you guys? Okay? So, looking at this, we will do 1 or 2 problems. Okay, you can note down this thing. But I think in this relative error also, the situation is this. I think they have made an error. Talking of errors, everybody makes errors. So the idea should be, for your relative error should be, this should be the formula. because your errors can only get added up, and outside you write a plus or minus. No, this is for your relative multiplication product and division. Okay, so we will write one, we'll do one problem now. This will make things very clear for you all. For remember, for multiplication and for addition and subtraction, what am I, 1 minute, what did I say? It's not delta A plus or minus delta B. It will only get added. The total we are telling it can be plus or minus. Getting it? Fine. There is an error of something. We are adding the errors and then we are telling at the end it may be plus or minus. Meaning this much error might be missing or it might have added. We don't know. This is the range. But, okay? Clear? Fine. So note down the problem. Note down the question. Maybe I can write it here. The length and breadth of a rectangle, the length and breadth of a rectangle are, I've written it on the screen, are okay, respectively. This is and, okay. Alright, the length and breadth of a rectangle are these values. Calculate the area of the rectangle with error limits. Calculate the area with error limits. First, what you can do is you can directly find the area with your known value, with using your known value. Do not consider the errors. This is the quantity. This is the quantity. This is the error 1. Okay. This is the error 2. Yes. Oh, you guys didn't know that. Okay, sir.
I do the same thing. I thought y plus or minus 4.
This is your error. This is your error. So this is how we write errors. Sorry, I do not realize you guys are not exposed to this. So this is how we write errors. So that means 5.7 is the quantity that has been measured. It may be plus or minus 0.1. That is the error.
Delta is 0.1.
Delta is 0.1. Again, second quantity is 3.4. The delta is 0.2. First you find the area and then you do whatever you want with the error, and your final answer will be area plus or minus error with the whatever the error you find.
So, sir, delta L, that's the error value for L, is plus or minus 0.1.
You can take it as, you don't see. So the thing is, again, at the final answer, no, see,
we are going to put plus or
the minus, so you just take the positive value, and at the end you write plus or minus. You just take the value as it is.
If you take the cost value, it won't be confusing.
It won't be confusing. Correct. Sign at the end you put. Okay. So for product, you know the rule. Let's see how many of you can do it correctly, because let's see. Maybe your minds will change if I write the formula down properly. You have seen the formula, but hello, Ananya, are you saying something? What? You can or you may not, it's up to you. Significant figures I have not yet taught it to you guys. So I'm excusing you from that. You got this in? Yeah, if you see, it's up to you. You can round it off to significant figures. If the question specifically asks you to do it, you do it. If not, it doesn't matter. All right. See, delta L you have. Delta L is the error. L is the original length. Delta B is the error. B is the original breadth. You are going to do this. On a RHS is also, this will be that delta A by A. Change in area by original area. So if you want to find delta A, after finding all this, you have to multiply A into this. That's all. Now.
After finding all this, we need to multiply A.
Yeah, because you have to isolate delta A, no? Down A is there.
Okay.
You have to take it to the other side. Delta L is, yeah, that's in the question, correct. Delta L is 0.1, delta B is 0.2. It's quite direct. You know A. Length into breadth, direct you multiply. It's how much? Correct. But you.
Is the product error plus or minus 0.07 something?
No.
So delta A, product error is 0.010.
No.
I mean, final answer.
Work it out at home. Let's see. But you understood the concept, right?
Yes.
It's.
So what's the final answer of the thing inside the braces?
The value inside the braces, right? Okay, so see, I have not 1 minute, so it comes to, see, around approximately this is what you'll get. Okay, Fine. Then when you multiply this value, okay, this much you got, no? And then delta A you will take to the other side. So you get, then I have calculated from this directly, into whatever A was, 19.38. Okay. Cancel, you get plus or minus 1.48. So this is going to be your error.
Oh, that's it.
Yeah. So why so much head you're breaking about it?
No,
Not everything in life has to be very complicated, man.
I thought we need to do the full simplification of it. Then
Why you have to when you can simplify this like this?
maybe I didn't understand what is A properly.
No problem. Now we will rush because I don't have that much time. So what you do is at the end, so finally what you write is your area is equal to, so what is the value of area that you get? 19.38 plus or minus 1.48. Alright? This is how you are going to write your answer. This is the form in which it's going to be. Now we are going to learn about something called significant figures. Basically the idea is that instead of saying this 19.38 and all, you can round off. That's all. It makes your life slightly simpler, easier. That's all. We scientific people, we don't like this rounding off and all, because we always believe that it removes the accuracy. If instead of 1.38 I tell 1.4, the 0.2 is an error that I am adding again. Correct? 0.02, sorry.
So
0.02 is the error.
We are also adding error.
Yeah. You are making it simpler for people to understand. See, it depends. Generally, if there is something wherein a kind of very high accuracy is required, there I am not going to round off. And see, that is the important thing. Now, for example, I have a door. Frame is ready. Okay, frame for this window is ready. I have to fit one window inside it. Okay. I have measured the frame, the hole to be, let's say, whatever, I'll take it as 1 meter wide or height, tall, 1 meter tall. Okay, into let's say 2 meters wide. If I make a window which is 0.99999 meter, it's not going to affect me because the difference is very, very small.
It's not what?
It's not going to affect me. You're getting it? 0.99999, as in the difference is 1 minus 0.99999, depending on this thing, it is going to be 0.0001 or something like that. So is that much small, that much distance going to make any big difference in your measurement? No. So there I will round off because I am not bothered that much about accuracy, because in this application it works fine for me.
Whereas in 0.9 meters,
It's a very big difference, and if I round off over there, my window is going to be 10 centimeters smaller. Understanding? Fine. So now on that note, we will look into something called significant figures. Okay. Significant figures are, now see, we have a lot of numbers. Okay. Significant figures. So significant figures generally, see, basically the idea is that how many numbers that I have of a particular value which are significant. It's a concept which you can read through and get to know because it's very theoretical, and generally I would like it if you guys read through it, then me explain, because it's kind of, not now. Close your book, man. Close. Not now.
significant figures actually in chemistry.
Yeah. So I am not going to go that much into the detail of it. I hope that is fine, because you guys can read through it. You can understand. It's nothing much. Even the problem is going to be, this is the number which is the significant figure. Round it off.
Just need to know the zeros, like we consider the initial 0 value.
So see, if the number is something like 255.25 and somebody asks you how many significant figures are there, you are going to say 5 because all of them look equally important. Alright. But now, if I have 255.011, okay, how many significant figures I have? Again I have 6. I have 6 only. I am going to count all of them because the 0 comes in between these values. So it makes sense. Okay, fine. But if my decimal zeros are before, how many significant figures I have? I have only 1. I am not going to bother about this because this last digit is the one that actually telling me anything useful about the measurement. Or here this 0 is a useful number because it is coming between. Correct? 101. The 0 is useful because it tells you there is a 100 before it. But this, it does not tell me anything useful for a measurement. This is going to be my useful this thing. Hey man, are you there? Yeah, okay. Fine.
Sir, whereas in 6.110, will we include the last 0 too? Because usually in decimals we won't include zeros, but whereas in significant figures we are including the last 0.
Yeah, anything after the decimal point we include it because that basically means that there's some sort of an accuracy about it. For example, if I tell you, provided that there is a decimal point.
No, provided there was some other number before the decimal.
Yes. If it's 32.00, my significant figure is 4 because it tells me, an engineer, if I just tell him 32, he'll know, okay, that's 32. If I tell him 32.00, he will know that it should not be even 0.01% more than 32. It has to be 32.00. Getting? That's why I add the decimal point. Okay? That's why it's called significant figures. If I have 32 into 10 to the power 5 or whatever, my significant figures become 2. Because again, this is what is giving me any kind of a useful information about the values. Okay? So you can read about this. I'm just going through it. There's nothing much more than this actually. But there is one concept of rounding off. Now rounding off is quite simple. Let's say I have 5.5. Tell me any number, random numbers.
5.593.
593. Alright. So the idea is quite simple. If I want to round off, what would I round it off as? No, that's very far. Let's do it to, so they'll tell you to how many decimal places you should round off. They'll tell you to 2 decimal places. Okay? So what will we round it off to?
5.5.
So there are 2 options. You could make it 5.59 or you could make it 5.60 like you said, which would be the next number. Okay?
That's for 1 decimal.
No. What will happen if I take 3 ka next this thing? 9 के बाद क्या आता है भाई? Okay, let's take a simpler number because it's at 9, it's confusing you. I'm taking 8. So what would come after this?
After 8.
Okay, so one option would be one option would be 8.3, one option would be 5.9.
Sir, but there is some rule that numbers below 5, for example.
Correct, that is what I'm going to talk about. So the idea is that if it is 8.3, no, the 3 is less than 5. So it should be 8 point, this one, this is the correct answer.
Yeah, it can't be 5.59.
Yeah, correct man, correct, relax. Yeah, so if it is 5.587, it makes sense that it's very close to the next one. If it's greater than 5, I put it over here. If it's less than 5, I put it over there. Okay. Now, let's say it is 5.325. So you know this concept already. The thing is that now I have a 5 over here. So what do? Do I take the previous one or the next one? The idea is that
The previous one is even or odd.
Ah.
So odd one means we will add 1, even we will just leave it.
if this is even, 2 is even, we'll leave it at 5.22. If it was odd, let's say 335, then I would add one more. Alright? Clear? That's all, odd and even. No, add one more. No? Odd.
5.325.
Yeah, the others it will not be odd. It has to be two different numbers in the number. Yeah. This is for an even case. This is for an odd case. Clear? Okay. Alright. So now, okay, we go into something interesting. Let's see how much time we have. Okay, we have decent amount of time to cover this. Good. Are you guys tired? Would you like a 5-minute break? Huh? Go. What?
Formulas, addition and product.
Is there in a textbook? You can just check it out. Everything is there. You don't worry that you did not write something. Okay? If you want, I can just show it to you. For which one you want?
Addition and product.
Ah.
Sir, can you go back to this?
Two?
After this.
1 minute.
Yeah.
This one?
Yeah. Yes.
So this is your product and division rule ka equation. Same one. Okay. Actually, okay. Alright. Product and division same. Errors get added up.
Whereas when we get exponents, we just multiply the exponent.
Very good, man. You have a good memory or something? You have a horrible memory? Do you have a horrible memory?
No,
They're doing quite well.
get confused. So
Very fast. Okay. I see. Very nice. Okay, this is our addition and subtraction.
So for the previous problem, at first you represented the answer like something, you put the error value, like what was, can you go for that slip? So area is equal to the actual area value plus the
Plus or minus?
plus or minus the error value.
Yes.
So this is what like, for example, engineers will represent like for something they take area and of different measurements, and if they get an error value, they will add. They will also show this was the error value
Correct.
we got like that.
Yes.
So why is it important to show the error value to with the actual values?
So that's in order to for you to be a good human being. For example, if you do something but you don't do it perfectly, if you are a normal person, you will tell you have done it. If you are a very good person, you will tell I have done it, but I have not done it perfectly. So it is very important for a good engineer to not tell only that he has done it, that he has also been imperfect to this degree. Because the thing is that if somebody else, now see engineers, and the thing is, see, if you are building a car, there's somebody else who is going to design the body of the car, there's somebody else who is going to do the engine, there's somebody else who does the other parts, maybe the seats or something like that, somebody else does the exhaust, somebody else does the radiation, somebody else does the suspension. There's so many different people working on it. Let's say one person did this and he did not mention the error bar, he left. The other guy comes. Now this is the size of the engine, the area of the engine. Okay. So according to this, he makes the area in which the engine has to be put. He doesn't know the error bar. So he makes it exactly 19.38 whatever in length and in width. Will the engine fit? If the engine is smaller, if it's minus, it will fit. If the engine is slightly bigger, it won't fit.
Okay, so they will see according to their value.
They will add one little, include it. They will include it.
To be
Safer. Okay, this is why errors are very important. The thing is, even we know we are imperfect. But the idea is, as imperfect as you are, be honest about it. Tell people that you are imperfect. Okay? Fine. So now we are going to look into dimensions of physical quantities. Alright? My handwriting is a mess, but as long as you understand, that's fine. Alright? So the idea is quite simple and it's quite beautiful as well, just like the idea of errors. Are you able to appreciate errors now?
Yes.
Are you able to find out what it is? And believe it or not, these error margins of sometimes 0.00 something is the difference that it makes between doing a successful moon landing and missing out completely. Between your Mangalyaan landing on the Mars orbit or it missing out completely. Such kinds of errors. Because what will happen is there will be one small error during launch. Very small. It will go through the atmosphere. There will be one more error. The two errors get added up. As long, immediately after some time, it goes into space. Okay, it is not perfect. It was supposed to go like this, it went little like this. Maybe something, some wind blew, something you cannot expect, right? Some small error, or it was supposed to go something, some kind of something happened. It was not going exact. Okay, slight mistake. That another error. The errors get added up. By the time it has reached mass, there are so many errors. But what we do is we always have a reverse mechanism to correct those errors. Just like your car, if you have gone too front, you can always put in reverse gear and you can go back. So we correct in that way. Okay. But errors have to always be taken into account.
That's why, like, if scientists are trying to do something, for example, a machine or a program, if they know the error, they will try to rectify it or reduce it.
Yes, at best, yeah. Correct.
So, like, how much ever they will try.
Because eventually it gets added up. And you will not know where it came from, because now you are working on such a big machine, some small thing would have done something, you would have forgotten about it, you worked on it 3 years ago. Okay? Understood? Okay, fine. I hope you are able to appreciate the concept of errors. And now we will look into the dimensions of physical quantities, which is a very beautiful idea. So the idea is that anything and everything, I can write it in terms of three fundamental quantities. I can write it in terms of mass, I can write it in terms of length, and I can write it in terms of time. Okay, that's all. Mass, length and time. Okay. Okay, M, L and T. So, do you know what momentum is? Do you know the formula of momentum? Yeah, but we can always initial velocity minus what? Okay, momentum is given by, I can write it as mv. Do you remember this? Mass into velocity. Now everybody remembers after I tell it. Okay. Okay. We don't have time. We'll talk later. We'll have to finish things first. Okay. Fine. So, Okay, mass into velocity. Mass, I'll write it as capital M. What is velocity? Formula. So V is equal to what by what? Distance by time, correct? V is equal to distance by time. So I can write it as distance is what? Distance is the length, no? So I can write L and time. So I'll write it as T. So I can write this as M L T minus 1. Okay? Just understand, just look at it, understand the concept. Similarly, if I have force, F is, come on, MA. So can you do this, the same thing for mass into acceleration now? Write it in terms of M, L and T. Come on, try. Break it down. Our M will be M only, capital M. Okay, try this out. Acceleration is velocity by time.
So it comes at a time.
So acceleration, see, acceleration I will write as velocity by time. So time I can write it as T, no? Okay, understood? But what is velocity? Distance by time. So M by T, this time is there, into again velocity is length by time. So can you write it together and tell me what it will be in terms of ML and T?
MLT minus 2.
MLT, okay, correct.
ML by T square.
Yeah, ML by T square, which is nothing but ML T raised to minus 2. Alright? This square I can write it up. Do you know this concept, right, of minus 2? Are you aware? Okay. I have to sometimes ask because some are not, and that's fine. We are all here to learn. If you don't know something, that's okay. After we teach you, you will know it. That's all. Okay? So, but are you clear with this kind of a thing? Do you want to stand up for 5 minutes and sit? Is it difficult to sit? It can be, I know. Okay, fine. So, basically, why are we doing this nonsense? MLT and all. Why are we doing all this nonsense? Any idea? Standardized? No. The reason is that it's quite a simple way. Now, from this, no, I can find what is the unit of an object. Now, what is M? Tell me. What is the unit of mass? Kg. What is that of length? So I can write M. What is of time? So kg meter second inverse. Can you see this? It's not that visible on the screen, but you got the idea, right? I'll write it bigger here. Second, I can get unit from here. When I was explaining, you are not looking at the screen.
I'm just thinking something kg meter per second square. So it's the unit for something.
It is for Newton.
Yeah, because
It is also called Newton. Okay. It is simplified and it is just said instead of doing kg meter per second square all the time, we'll just say Newton. Okay. It is simplified. Yeah. Good. Okay. So this momentum, can you do the same thing? From mass, mass is obviously kg, length is meter second per second, that's all. Kg meter per second. Simple. So this is one smart, okay, it's okay, I'm covering it, no? Okay, this is one application. I can easily find out my units, and there is a bigger application to this. There are bigger applications to this, and that is to check if the dimensional, if I have an equation, I want to check if it's dimensionally accurate. Let's say you are a big scientist, okay, and today you have tried something new and you have discovered a mind-boggling equation, okay, and your mind-boggling equation is V is equal to U plus AT. Do you know this formula? So now you want to check if this equation, you are checking in many ways if this is correct. But there is another way in which you can check, and that is using this method to check if it is dimensionally correct. So what you will do is, first I will break it into two, my LHS and my RHS. So what is my LHS? Write this for me. Come on. You are the scientist. You should be doing this. You are the scientist, you are the engineer, whatever you are. Come on. Ananya, I hope you are able to follow, okay? Wonderful, you given the answers and everything. Awesome. Okay, so what is your, no, 1 minute. See, I want you to tell me, do this for the LHS, okay? V, velocity. So can you write it in terms of M, L and T? Do that. Let them also do it. No, don't tell me the unit, just tell me in terms of M, L and T. Okay, you can do the unit also, that's fine. But mainly I am interested in terms of M and L, M, L and T.
M be necessary or just L and T? So because M does not.
M does not?
I mean, for the LHS,
M.
M.
So you write M to the power 0.
So M should also be written.
You always write M also.
So, sir, should we write
If it is not there, you write it to the power 0.
should we write E as L by T?
Yes, mass is equal to,
Distance by time.
so that is L by T.
Velocity is equal to distance.
So it will be L by T.
L T to the power minus 1.
Yeah, but M is also there. I want you to write in terms of M. M, L and T. So M, what you do, you write M to the power 0.
Okay, so that even if it's there or not,
It's equal to 1. You got that, man? Okay. Yeah. So LHS means left hand side. RHS means right hand side. That's all. So now I want you to write this in terms of M, L and T. V is what? Velocity. Okay. So what is going to be your V? Velocity is formula. You know it is distance by time. Okay. Distance by time. Distance is nothing but L, no, length it is. And time is T. So it will be LT minus 1. Okay. But I want in terms of M also. But M is not there. So what I will write? I will write M to the power 0. L T minus 1. Okay. So M is coming, but it is actually having no value. RHS, do it now. Come on.
sir, is it
It.
correct for LHS?
I'll come to that. Come on. Huh? Yes, it is correct, man. Now do it for you and do it for AD. Do it for AT. That's you did. You said then. I understand. Huh?
I'm getting into. I mean,
I know you're getting a 2. We'll talk about it in a while.
But I get it correct.
You did it very correctly, man. You're amazing. Okay. We'll talk about that too. I want you to get that too. It's actually invalid, but you get it. It's fine. We'll disprove it in a while. What is acceleration?
velocity by time.
Acceleration is velocity by time. M velocity is distance by time. Okay. Hey guys, take some 5 minutes and revise your these equations. It's very easy if you just go through it. Velocity, distance by time, acceleration, velocity by time. All these three, if you go through it in 5 minutes now, you'll remember it and you'll know it. That's all. Okay. So spend those 5 minutes.
Sir, so U plus AT, we can represent it as U plus LT to the power minus 1, the whole divided by T. Yeah, I'm just saying that.
Then you cancel and you tell, man, you do the whole thing and you tell me. Do it for U also, okay? U is what? Initial velocity.
U is initial velocity, okay, V is final velocity. The 9 standard portions I need to.
No problem, you do it.
So U is also velocity.
Correct. It is going to be the
LT.
same. Yeah, it's going to be same. M naught M to the power 0 L T inverse. It's same, right? You got it, bud? Okay. What has happened now? This is for which one? This is
for
UT, no?
AT.
Sorry, AT is
Velocity by time.
so it will be L. Come on, you're doing it right. Come on. L is there already, correct. What is remaining? T got cancelled, but one more T is there. Perfect. Awesome. Okay, same thing we have to do for U also. Okay, we forgot to.
M raised to 0.
It will be same. M raised to 0, L, T minus 1. Okay? Okay. You understood how to do this, right?
Yes.
Okay. You can do it then. So the confusion right now is the 2. So on the LHS V, what are we getting? Can you just tell me the answer quickly?
M to the power 0 LT
Minus 1. If you do the same thing for U also, no? You will get M naught LT minus 1, obviously. For AT also you will get M naught LT minus 1. So the problem is at the RHS, can I add these two up and will I get 2 M naught this thing? Okay. So no, we don't add it up. Okay. We just write this is the LHS and this is the unit at the RHS. Basically the idea is, if I tell you he has half a kg and another person has half a kg, you add it up, it makes sense to say I have 1 kg. But can I tell I have 2 units of a kg? The kg cannot become twice. Understood? The unit remains the same. Getting the idea? The unit does not change.
So, but if we just substitute the whole and
If you just substitute like that and you add it, it will tell to this thing. Okay. So what these people generally do is they separate these into 3 parts and they say, oh, the first part is giving me this answer, second part is giving me this answer, third part is also giving me this answer. You can write it as LHS and RHS as well. You can write it as 3 separate parts. You don't add it. No, you don't add it. Because you cannot add the unit. You can add a quantity.
I'm telling that we should not substitute the whole thing and then just.
No, don't directly add it. Okay? I wanted you to get through that so that we would have this question so that we could think about it. Can unit be added up?
Yes.
Quantity can be added up.
No, I have 2 units, 1 unit and 1 unit. So
But that is a quantity. One is a quantity.
oh, different units you are asking, sir.
No.
Same units.
What is a
So,
You got the point. No.
No, sir. If you are saying if
Imagine. Talk less and imagine. Hey, you don't laugh. Who told you to laugh? I'm a strict person, okay? No laughing. Imagine I have 5 kg of something. 5 is the quantity. Kg is a unit. Kg does not have a number actually. Kg is just I'm putting in front of that. It is an idea. You're getting the value is in what 5. 5 is the quantity. Kg is just a unit. Okay. Can I add 2 units together? You cannot add. You can add 5 plus 5. The quantity gets added. It will become 10. But the unit is just an idea, I am telling. You getting the point?
sir, wait. I'm getting the
If I tell I added 5 drops of water and another 5 drops of water, it becomes 10 drops of water. The quantity increases. But how do I explain this? But
unit remains the same.
the unit remains the drop of water. Unit does not become 2 drops of water.
In this case, sir, we are taking m to the power of 0 and t to the power of minus 1. Like we are getting 2 m to the power of 0 and t to the power of minus 1.
Okay, can you write this in terms of kg, meter and second? Can you write this in terms of kg, meter and second? Okay, so what will this be? Kg to the power 0, kg is not there, it's 1. This will be what? Meter. This is?
Per second.
So it will be meter per second. Second raised to minus 1. Understood, no? Meter per second. Meter per second. Meter per second. This is only a formula. It has no quantity. Can I tell there are 2 meter per seconds are here? Does that make sense? No. If I am defining a quantity, I can tell something value, something like that, it is getting added up. But the unit is not getting added up. There is no meaning in saying there are 2 meters per second.
Here we are just seeing for the
Unit.
We are not even
It's not nothing to do with the quantity. It's only about the unit. To check. Okay? Is that fine? Alright? All good? Everyone clear? No doubts, right? You go home, you sit and you think about this for 5 minutes nicely. And you'll get it. Okay? You imagine it's a concept that you have to understand. What I believe you have understood it. Huh? Tell me.
I didn't get even 80s. I just studied from here. I still didn't understand what is the
After the class, you discuss with these people. They have gotten it, because the thing is, if we go back to this, if we discuss back and forth, we will not be able to move ahead. Is that fine? Is that all right? Or let me just quickly do it. Come on. Or let me do it here. What is U?
only for the RX. You use velocity, initial velocity. So it is LT to the power minus 1.
Velocity. Velocity is nothing but
L by T.
is simplified distance by
Time.
or displacement by time. Okay, velocity is displacement by time. What is displacement in terms of MLT? Displacement is L.
Displacement.
Distance is what? L or T?
Distance is L.
Correct. Divided by.
T.
So what
LT
will?
to the power minus 1.
Okay, but I want to write it in terms of MLT. So I'm going to write m to the power 0, because that becomes
Same thing here.
everywhere. Okay.
And for AT,
Same thing. AT is.
AT is velocity by time.
Listen, acceleration is velocity by time, okay, into time. So what do I have remaining?
Again, velocity, again, 17, same thing.
Distance by, or I can just write by time. Okay. Same thing, buddy. Everything it cancelled out, it becomes the same. Okay, you just solve it once. Go home and solve.
I'm so sorry, sir, to ask it out. But I don't know why we are multiplying times, sir.
Because it's A into T, right?
AT, oh, T, oh, that T.
You forgot the T. That's all right. You just wrote A. Okay, but you got it now, right? It's very simple. It's to be honest, it's no difficult thing. You got it, nobody?
I didn't see T, no, AT, I was doing the A.
Understood, buddy. Awesome. Let's move forward. Okay. Okay, fine. So, and one more thing you can do is, it says here that you can convert a physical quantity from one system of a unit to another. But now, I think if I discuss this, we will again have many doubts and discussions. But all you need to know is that a physical quantity multiplied by its unit will always be equal to another physical quantity multiplied by its unit. All right, this ratio will be always maintained. All right, just remember this much. Okay, so I can tell maybe here they have written n1 u1 is equal to n2 u2. All right. Okay, this is, will not go into the details of this. This much is enough for you. All right. Having known this, you can always recalculate things and you can find the quantity. For example, I know 5, I know in kgs. I want in grams are here. I'll put grams are here. If I recalculate, I'll get the value of how many grams it will be, N2, in terms of that. Okay. It is just direct 2 1 4 calculation. Now, another interesting thing is, you can actually derive any particular relation among physical quantities using this. So for example, now if I have a pendulum, let's say you are a scientist or you are an engineer, you are somebody, you take this pendulum, okay, and you want to see its the dependence of time period on various parameters.
Dependence of time.
Time period means how long it takes to make one oscillation. Okay, the pendulum is going to go like this, right? So how long it is taking to make one oscillation, that is time period t. Okay, so what are the different parameters which could affect this?
Which could affect this.
The time period. Let me give one example. One is the length of the string.
Weight of the ball.
Okay, another, very good, is directly proportional to the mass. Okay, and another thing is not air pressure and all, that is actually is relevant. Okay, that's very good answer, because only in vacuum will I get a perfect pendulum and all of those things. Yeah, but another relevant one is gravity. Understood? So now what I will do is, I will very smartly, I am going to tell you that, okay, so T is proportional to the length, T is proportional to the mass, T is proportional to my gravitational acceleration due to gravity.
So is it weight, sir? When we say gravity, is it weight what we are talking about?
The force of acceleration due to gravity. Gravity is,
Force of acceleration due to gravity is weight.
that multiplied into mass gives you the weight. Ma is the weight. Ma is also the force. Your force that you are putting on the earth is the weight. Your weighing machine, when you stand up, your mass into the acceleration due to gravity, you are putting a force on the weighing machine. That force is being measured in terms of kg. It tells you in kg how much is the force you are putting. That is your weight. That's all. Alright? Simple. If I go to moon or some other planet, my mass is going to remain the same, but the gravitational force is going to be different. If I go to space, the g might even be 0, because there is no force due to gravity. In space, on earth, the earth is pulling me towards it. In space, what is there to pull me towards it? Nothing. So what is the force I am going to experience due to gravity? Nothing. So what is going to be my weight in space? Nothing. I am going to experience weightlessness. I will float around. Clear? Not in the syllabus, but just a discussion. Understood the concept, right? Okay. So D is directly proportional to L, M and G. Alright. But if I want to equate this, can I directly equate things? If they are directly proportional, does that mean it's equal? It's not. So in order to equate this, we put a constant of proportionality always. Do you know about this constant of proportionality? Okay, good. Fine.
K is constant of.
K is a constant of proportionality. Okay, but now I want to write this in terms of units. So can you guys write this in terms of M, L and T now for me?
kg, meter,
Because we are going to do something interesting. Come on, I want you to do this.
M is mass.
Yeah. So what we'll do is, we'll write this in terms of, see, this will be in terms of T. K will keep her here. I'll write L raised to X, M raised to Y, G raised to Z. Okay. The product, I can write it as this. I can write it as this. It may have any value. If it's only L, it will be raised to 1. Understand? Because the thing is, I only know they are proportional. I don't know how. I don't know if it is proportional to L square or if it is proportional to M square. I don't know what the relation is. You getting it? Let me show you the idea. The idea is this. Let me just solve it and maybe you'll get a better idea. Okay. Okay. So what I'll do is, now I'll write T in terms of ML and T. So what is it going to be? M raised to 0. It's time, right? So what? L raised to 0, m raised to 0, L raised to, correct, T raised to, it's not -1, it's 1. Okay. K is as it is. What is L? L is the length of our string. So what is m going to be our here? M raised to 0. L is the length of the string. So L will be 1. And what is going to be our T? Correct. This raised to x. Okay. Yes, every time. Okay. Okay. Now what is going to be our m? For second one it's mass, no? 1. L will be, correct, T will be, correct, y. Now into G. What is our G? Is acceleration. So what is our acceleration thing? Velocity by time. Velocity, we have done this before. I'll just copy paste it rather than
velocity m0 at 1 t1
m0l.
minus
1 minute. It's not going to be that. I have solved it somewhere here. Okay, let's just do it here. By time, velocity is distance by time. Okay, L, correct. Okay, Z. Okay, so now I'm going to equate these two. I'm going to write, equate the powers of this. Okay, first we are going to equate the powers of m. This is one way of solving it. Okay, buddy, the idea is that always the powers of this particular quantity, it is balanced. Okay, you guys are probably not aware of all these concepts, right? They are new to you. Would you like to start this in next class? Huh? Rather than eating more of your head right now. I actually thought we could finish the unit today. Huh? Is that better? Can you then go home and go through these things and then we'll go through it? Is that fine? Okay. Okay. So, but I want you to do one thing at home. This is maybe your homework. Similarly, do this dimensional analysis for S is equal to ut plus half at square. You know this equation already. Do it for v square is equal to u square plus 2as. Okay? Huh? Yeah, this is your homework. Do it and send it to me on the group, WhatsApp group. My main aim is that you should understand it. I'm not bothered if you do it or not. You can even copy it from anywhere. I know that. But the point is you understand it, because otherwise next class you only will be confused. Okay? Half 80 square. 1 minute. What? Okay. All right. This is some interesting stuff. Okay. Velocity is the same thing. Initial or final or middle, doesn't matter. Acceleration is also the same thing. Final acceleration, initial acceleration. It just means what is the quantity of acceleration in the beginning and in the end. That's all. Okay. If I tell final time, initial time, that does not mean time is a different thing. It just means time at the beginning, time at the end. That's all. Okay. S is 2s is displacement. S is displacement. Okay. You have studied this equation in 9th, 10th and all. Very basic. You guys need to know this stuff. Others going ahead, instead of becoming a 11th standard teacher, I'll become a 9th standard teacher also. Huh? Corona, my God, is gonna make my work difficult. Ananya, with this we are ending today's class. Okay. I think everybody is quite saturated are here as well. So I told them we'll continue. We'll do this again in the next class. I think. Okay. But did you understand everything that was done till here?
Yes.
Yeah, sure. Okay. Okay. Take care, Ananya. Okay. Ananya, what you can do is see, we have made a WhatsApp group of us are here. maybe how can I add you to that group?
Should I
Hmm?
give my number?
You have my number, right? I had given it in the last class. You just drop me a text, Ananya, and add you to the group.
Okay.
Okay? Alright, take care. Bye.
I do all the sleeping. 17 hours of full sleep. Because I'm going to drastically.
17 hours. What are you? You are not a human being. Does not work.
Sorry, I live like a Batman for the whole text.
That's not Batman. You are not man only.
I slept 4 hours, 3 hours, so I was preparing for test. Now I'm enjoying it.
Okay, anyway, see, however you studied in standard 4 hours and all, that's not the normal. Things are quite complex, and things get added up. You see, so many different concepts you have discussed, and barely one unit is done. You see that what in 10th standard you used to do for 2-3 units, and here it is done in half a unit. There are many different concepts are there. In 10th grade, slowly we used to teach. I get that one of these. You guys want to be good at it, Excel and all that. You have to start studying now. You have to know your concepts inside out long. Later on, you study before the exam. Now you know what to study also. 4 hours before the exam, you think, okay, that 1 night before I study, I should do that also. But, and I have realized that you won't know from where to start. Understand? Okay. Anyway, that's it. If you guys are on vacation, spend your time on something for your doing development. Start doing it properly. Do some 2-3 programs, run 2-3 programs. Make some 2-3 games. Not only you have the time. Good. Good. Also do something. Very good. Excellent. Right now using this is spider and everything you can
We also went for Python classes for data analysis and stuff programming. So yeah, I got certification stuff and stuff. But like after a while, I didn't keep replacing. So like a lot of concepts I forgot, so I just think I did.